You know, on any construction site, this is the real challenge. How do you take a flat 2D drawing and turn it into a complex, breathing, three-dimensional facility? It's a process that's just loaded with risk and detail. Success isn't just about what you build, but exactly how you build it.
Okay, let's get right into it. A drawing like this, it answers the first big question, right? What are we building? I mean, you can clearly see the general layout. We've got 6 big chillers here, pumps over there, all the pipes connecting them. It shows us the finished product. But here's the thing, a picture of the destination is not a map of how to get there.
And that, right there, leads to the most critical question. This is the one that separates a smooth, successful project from a chaotic, expensive mess. How? How do we sequence all these tasks? How do we make sure every single person on site goes home safe at the end of the day? Well, the answer is the Execution Management Plan. It's the foreman's playbook.
So here's what we're going to cover. We've just touched on those 2 big questions, the what and the how. Now we're going to dive into the construction master plan. After that, we'll follow the journey of a single chiller, cover the essential rules of the game for quality and safety, and then wrap up with the daily playbook that makes it all happen.
First things first, every major project needs a high-level roadmap. In the biz, we call this the Work Breakdown Structure, or WBS for short. This is the big picture strategy that takes us from an empty piece of land all the way to handing over the keys.
Think of the WBS as breaking the whole project down into logical chapters. And it has to be a bottom-up sequence, right? You can't place heavy equipment without foundations, and you can't even start on foundations until the site is properly set up. So we mobilize, we build from the ground up, we place the big gear, connect everything, and finally test the whole shebang to make sure it works. Each step unlocks the next one.
Okay, so that was the 30,000-foot view. But to really get what execution is all about, we've got to zoom all the way down to ground level. Let's follow the journey of just one critical piece of this puzzle, a single chiller.
So looking at the schedule, we know exactly what we're dealing with. 6 of these big, air-cooled screw chillers. And you can just tell, these things are massive pieces of industrial equipment. This isn't something you can just nudge into place with a forklift. This requires a precise, engineered operation.
And here's the thing you got to get. This isn't a single action. It's a meticulous 5-step process. First, you survey and mark out the exact coordinates. Then, you construct the reinforced concrete foundation. After that, you prep for the complex lift. Then, you do the lift and place the chiller. And finally, you grout and anchor it down for good. You can't skip a step.
But look at this. Right out of the gate on step 2, bam! We hit a wall. We're ready to pour concrete for the foundation. We might know the density we need from the drawings, but that is not even close to enough information. The whole operation is blocked. So why are we blocked? We're missing the detailed structural drawings. I mean, without them, how is the crew supposed to know how thick the foundation should be, or what size rebar to use, or how to space it out? If you try to guess, well, you're just asking for a disaster that could compromise the entire structure. So everything just stops. Full stop.
All right, let's imagine we get those drawings. The foundation is poured, it's cured, we're good to go. We move on to step 3, prepare for the lift. And, you guessed it, we hit another wall. The rigging crew is standing by, but they can't do a thing. We're blocked. Again.
So what is it this time? It's the manufacturer's official equipment data sheet. This is a huge deal. Without it, you don't know the exact weight, the certified lifting points, or the machine's center of gravity. Trying to create a lift plan without that data, it's not just unprofessional, it is flat out dangerous and negligent. Safety comes first, so all work stops until we have that document in hand.
Okay, so let's fast forward. We've got all our information. Now the lift itself, it's like a well-oiled machine, a total team effort, and this really shows you just how specialized these roles are. The rigging foreman, he's the quarterback, running the entire show. The crane operator's hands are on the controls, but they often can't even see the load. That's where the banksman comes in. They're the operator's eyes and ears. The riggers are on the ground, handling the gear. And you've got an engineer there to witness and give that final thumbs up.
Now, once that chiller is in place, you're not done. There's one last super critical step, grouting. And let me tell you, this is where a really common and costly mistake happens. You get a weak bond. And almost every time, it's because somebody didn't clean the concrete surface properly. The fix is so simple. Just follow the manufacturer's spec and make sure it's spotless. That little detail prevents huge vibration problems later.
All right, so we just went super deep on one single task, right? Now let's zoom back out and look at the systems that govern the whole site. How do you make sure every single task, big or small, is done right and done safely? You need a clear set of rules for the game.
This is how you guarantee quality in the real world. It's a process, a work inspection request, or WIR. Think of it like a series of green lights. A foreman's crew finishes a job. The foreman submits the WIR. The project's own quality control team comes and inspects it. If it's good, the client's engineer signs off. Only then, only after that final approval, can you move on. It's a system that locks in quality at every single stage.
Now that sounds great, right? That's the perfect world scenario. But we all know the real world isn't always perfect. Things don't always pass the first time. So what happens when the quality control team finds a problem and rejects the work?
Okay, so if a nonconformance report, an NCR, gets issued, the rules for the crew have to be crystal clear, non-negotiable. Number 1, stop all related work immediately. Number 2, make the area safe. Number 3, wait for clear instructions from the foreman. And the absolute golden rule, you never ever hide a problem. Being upfront and honest is the fastest way to get it fixed right.
Okay, let's bring it all home. When you take all these pieces, the master schedule, the step-by-step methods, the quality checks, the safety rules, what you get is your daily playbook. This isn't some document that sits on a shelf. It's a living tool for foremen and their crews to win the day, every day.
And if you remember one thing from all this, let it be this. A great execution plan is not just paperwork collecting dust. It's a communication tool. It is not some rigid script you have to follow blindly. It's a framework that helps you spot problems before they blow up. It's not bureaucracy. It's the playbook for getting the job done safely and with quality.
You know, there's a quote that just nails it perfectly. No plan is a crystal ball. It can't predict that a water pipe is going to burst or that a delivery will be late. That's not its job. Its job is to prepare you and your team with the right processes and the right logic to handle whatever the site throws at you.
So, I want to leave you with this question. Think about your own projects. What's the one piece of missing information, that one missing drawing, that one missing number, that stopped you dead in your tracks? Because really thinking about that is the first step to building a playbook for the future that's truly bulletproof.